Okay, in this video we're going to be talking about parametrization of a curve. And so we're going to be looking at three different examples and three different ways to parameterize. And when you're doing parametrization, I mean, there's so many ways that you can do this. This is just one way that I want you to consider, and perhaps maybe an easy way just to do it. So what we're going to do is we're going to construct parametric equations. All right, so that's what we're going to do here. We're going to make the parametric equations first. All right. So once I've got those down, then I can parameterize the curve. All right, so parametric equations. So I'm going to start off with, all right, and let's say I'm looking at this one, and this is the line segment with endpoints 7, -6, and 10, 3. So this is the beginning. This is where it starts, okay, and this is where it ends. All right, so let's say that I say x equals some parametric equation with 7 involved, and I'm going to say 7 plus some number a times the parameter t. And this is, of course, we're going to assume here that we're looking at time t equals 0. All right, but let's continue, and I'll write that down in a minute. Y equal now -6 plus some number bt. All right, and again we're assuming that these right here represent okay, a line going through the point 7, -6 at time t equal 0. All right, so think about it. When you plug in 0 here and here, what do you get? 7, -6. Okay, you get 7, -6 exactly. All right, so what we're going to be tasked with then is to determine a and b so that the line also goes through the point 10, 3. So let me write that down. All right, so it says we determine a and b. Let me space that properly. So the line goes through the point 10, 3, and we're going to take this, suppose, at t equals 1. So let's say from 0 to 1 seconds, beginning and ending. All right, and that's just an idea that you can use here to parameterize the curve. All right, so what do we say then? Well, we're going to say 10, which is an x value, because this is x and this is y. 10 will equal 7 plus a times 1, and then 3, which is the y value, will equal -6 plus 6. I'm sorry, plus b times 1, because we take t equal 1. So 10 equals 7 plus a here, and 3 equals -6 plus b. And so it's easy to figure out what a and b are. In this case, a will equal 3, and in this case, b will equal, let's see, 9. All right, a will equal 3, b will equal 9. So we can easily come up with our possible parametrization. So let me write that down. Possible parametrization, because answers can vary here. You could come up with something totally different if you approach this in a different way. I mean, if you approach this maybe from a trigonometric perspective, you might come up with some other solution here. But 7 plus 3t, because we're saying a is 3, and then y will equal, let's say, -6 plus 9t. All right, and of course we are looking at values of t between 0 and 1. Looking at values of t between 0 and 1. All right, and so that's what we've got there for a possible parameterization. So let's go ahead and take a look at another example. Okay, so this one right here, number 5, says we're looking at the upper half of the parabola, x minus 8 equal y squared. So it's a parabola oriented sideways, okay? It's oriented sideways and it's facing to the right, if I'm not mistaken here. But what we're going to do is we're going to say, okay, well, there's nothing to this, all right? Because what happens is that this is going to follow what we call a natural parametrization. So I can first of all say, if I solve for x equal y squared plus 8. And this is how I know that it's facing this way. So it's a parabola that looks like this, first of all. Okay? But what I'm going to do is, if we're looking at the upper half, this means that the y values have to be positive. So y values greater than or equal to 0 is the first thing. But in a natural parametrization, what you do is substitute t for y. So that's what I'm going to do. Substitute t for y. All right. You will say, in this case, in your possible parametrization, let's just write that out. Okay, first you're going to say y equals t. All right, but since y equals t, you can then say, well, x equals t squared plus 8. So I know it's kind of working backwards there. All right, but nothing really to it. And since y equals t, and we said y, if we're looking at the upper half, y is greater than or equal to 0, then we must also consider t's that are greater than or equal to 0, because we're only looking at this upper part here that I'm highlighting on this little graph that I sketched. All right, so that right there is your possible parametrization, all right, for this one. All right, and it's really not that bad. All right, this next one, a little more involved, but you'll see why in a minute. We have to do a little bit more. All right, and I mean, you could probably approach it like you did the first one that we looked at in this video, but let's take a look at this one another way. So it says the ray, which is half a line, and this is what I'm looking at here. This is what I'm picturing as a ray, something that looks like this, okay, because the other half may go in this direction. All right, so the ray, half a line with initial point negative 4, 6, that passes through the point 4, 0. All right, so we're going through the point 4, 0. All right, so let's see here. We're going to assume that x and y are linear functions of t, and that the initial point xy starts at 4, 6. So xy starts at negative 4, 6. Negative 4, 6. There we go. And this is going to be when t equals 0. All right. And so then, let's say when t equals 1, it passes through 4, 0. All right, so there's kind of where we're going with our parameter here. So we're going to say then x is some function of t. All right. And then we're going to say, well, when you plug in f of 0, you get negative 4. Okay. And then when you plug in 1, so f of 1, you're going to get a positive 4. All right. So that's kind of important to note here. All right. And then we're going to come back to this in just a second, but let's take a look at y. So y is going to be some function of t, and we're going to call it g of t. And when you plug in 0 in for y, in the y, what should you get? You get 6. G of 0 equals 6. All right. And then when you plug in 1 into g, you're going to get this right here, 0. All right. So what we're going to do here is we're going to come up with these, using these 2 points, a linear equation for each of the parameters. All right. So what I can do, again, we're assuming it's linear, is I'm going to find the slope. All right. I'm going to find the slope. And I'm going to say, well, the slope is delta x over delta t. Let's see what that looks like. So this is going to be the final, which is 4 minus a negative 4. So the final minus the initial over the change in time, 1 minus 0. So what do I get here? 8 over 1, which is just 8. All right. So the slope here is 8. So if I take my x equal to f of t, what do I get? Well, I'm going to get a slope of 8, 8t minus 4, my y-intercept. This, of course, was my y-intercept. All right. And you can write it in that parametric form to say negative 4 plus 8t. All right, negative 4 plus 8t. All right, there's your parametric equation there. Now let's take a look at the y one. All right, so if I'm taking a look at the y, I know I'm again going to find the slope. And I'm going to say, well, it's just delta y over delta x. Okay, I'm sorry, delta t. So you're just writing x. All right, so this is going to be 0 minus 6 divided by 1 minus 0, which is a negative 6 over 1, which is negative 6. And so y equal g of t will be the negative 6 slope t plus the y-intercept of 6. All right, and then you're going to write this, of course, in parametric form. So it's going to be 6 minus 6t. All right. So the possible parametrization, let me write that out. I think it takes longer than actually saying what I'm going to say. It takes longer to spell. All right. The possible parametrization, x equal negative 4 plus 8t, and y will equal 6 minus 6t. All right, and we are looking and considering values of t that are greater than or equal to 0, because again, we started off with 0. We assumed t was 0 here. All right, because we are also looking at something that's really rising. So if you think about it, we start off with t equals 0, so we're going to take values of t greater than or equal to 0 here for the possible parametrization. So this is what we will get for that answer there. All right, so again, 3 really nice examples of where we parameterize a curve. And as always, I hope this video is helpful. And remember, like and subscribe.